right, so this one, and please reread this. A lot of it's not important, but I did notice these words here, linear relationship, which means line sort of equation. I also noticed that there's two sets of numbers, the 70 with this and the 80 with this. So let's just say, for example's sake, I'm going to write that 70 with the 120. I'm going to write it like this, 70 with the 120. And then I'm going to write the 80 with the 160. And basically the question is, write an equation, right? So instead of x and y, right, instead of an x and a y, we have a t and an n, right? T for temperature, n for number of, well, n, it says terps per minute. There we go. So t and n. But that's really not important for the moment. I just want to know, I want to treat these like an x and a y because I know that I can figure out an equation from this information. You probably don't remember this, but there was two ways to write an equation. One way was if I had the slope and the intercept. So if I had the slope and I had the y-intercept, I could write the equation. I don't have either one of those things. Another way was if I had a point. Right? If I had a point and a slope, that point, the x and the y, and then the slope, I could write an equation. Well, the third way is actually based on the second way, but what happens if you just have 2 points? How do you write the equation? Well, the way to do it is, number one, you're going to find the slope. And then the next thing you do is you're going to switch to this method. Well, once you find a slope, well, then suddenly you have a slope and you already had 2 points, which means you have at least one, right? Then you're going to switch to this method. So find the slope, but once I find the slope, I can switch back and use this to do it. So fortunately, there's a slope formula. Slope formula. Ignore the t and the n for a second. Slope formula is y2 minus y1. x2 minus x1 is the slope, and basically what that's saying is the change in the y's over the change in the x's, right? How the y's change, how the x's change. So I'm going to use this formula to find my slope up here. So let me go back up a little bit and forget the t and n. Let's think x and y. So the slope formula equals, and I'm going to first x, first y, second x. So y2 minus y1 over x2, 80, minus x1. 160 minus 120 is 40. 80 minus 70 is 10. So the slope is 4 over 1, or just 4. That's the slope. Okay. Now I'm going to write my equation, right? By using this thing right here. So y minus, and it really doesn't matter which one of these I pick. I'm going to pick the first one. Y minus y1 equals the slope I just found, x minus x1. So y minus 120 equals, and distribute this 4x minus, what is that going to be, 140? 4 times 70. Add the 120 to both sides. And I get y equals 4x minus 20. But now I don't want to use the x and y. Remember up here, they want it in t and n. So the n is kind of like the y, the t is like the x. So that means I'm going to write n equals 4t minus 20. You may have to watch that a couple times. Now, once I have that, I'm going to ignore, get rid of all this. Boom, 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 boom. I have my equation. Come on, goodbye, 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 goodbye. All right. I have my equation says use this function to determine the rate at which the crickets chirp when the temperature is 95 degrees. So now we have a new t, find the rate. That's the n. Well, it's right here. So my t, so now I'm going to say, okay, what's the number of cricket chirps rate per hour, whatever that means, equals 4 times this t, 95, minus 20. I just used this formula I created to find my answer. 4 times 95 would be, oh gosh, what is that going to be? 190, 380 minus 20. I did that in my head. I don't know if that's right. 380 minus 20. Okay, I got to check it. I'm sorry. Turn my calculator on here. 4 times 95. 4 times 95 is 380. Oh, good, I did it. 380 minus 20 is 360. So it should be 360.